All right, what's up, y'all? Math and Beats, video time, and we are going to talk about something in mathematics which is called a difference quotient. Let's see what that is. All right, so before we formally say what difference quotient is, I want to refresh what the average rate of change of a function is. Remember, we got a function, f of x, let's say, and we want to find the average rate of change from x is a to x is b, then we calculate as below. Notation here, sometimes we write average rate of change acronym, AROC, over the interval a to b. For the function f is just defined to be the difference in the values of the outputs of the function, that is f of b minus f of a on top in the numerator here, divided by the change in the x direction, the horizontal direction. So that is just the same as the slope of the secant line, remember, passing through the 2 points of interest on the graph of f, a comma f of a and b comma f of b. Here's a picture of it, and remember here we got in the picture interval a to b, so the change from a to b is just the value b minus a. That's the change in the x direction. And the change in the output direction up here, just the value f of b minus f of a. That's change in the output. And this secant line right here, the red line, is the secant line through the 2 points a comma f of a and b comma f of b, and that line has slope which is equal to the average rate of change of the function over the interval a to b. So there's your refresher. Remember, in general, what this tells us, this slope of the secant line, this average rate of change, is how many units of f have changed per units of x on the interval a to b on average. Now we talk about this average rate of change first because really, as we're going to see in a moment, difference quotient, just pretty much same thing, different notation. So let's see what the difference quotient is. All right, here we go. Difference quotient. The difference quotient for a function, again, let's call it f of x, is just slope of the secant line, hence average rate of change of the function. But now, instead of calling the 2 points a comma f of a and b comma f of b, we're just looking for the slope of the secant line connecting the arbitrary points x comma f of x and x plus h comma f of x plus h, assuming h is not 0. So what the hell does that mean? What's this notation here? Well, again, first we're defining it to just be the average rate of change over these 2 different points on the graph of f. 2 different points, as stated above, x comma f of x and x plus h comma f of x plus h. It's really just saying what's the average rate of change of the function over the interval x to x plus h. It's kind of weird notation, but it works, and in fact it's very important notation once you relate this idea to calculus. If we wanted to calculate the average rate of change over this interval, then same thing. We just take the change in the output direction, which here is the difference between the outputs f of x plus h and f of x, and divide that by the change in the input direction, change in x, down here, which is just x plus h minus x, which just leaves us with a value of h. So h is really our difference in the x direction here. That is one advantage of using this notation, again assuming h is non-zero. So here's a picture to help us understand. Again, we just pick 2 x values and consider the interval for which we want to find the average rate of change. So there you go, you're going from x to x plus h, and the distance between those 2 x values is just some distance h. The corresponding output change, f of x minus, or excuse me, f of x plus h minus f of x, That's change in the output direction. That's just your corresponding change in y, the output direction. So you take the quotient of those two things, f of x plus h minus f of x, and divide it by h, and that is what we usually refer to as the difference quotient. All right. Now, let's just do an example here to see it at work, since it's really just average rate of change with a different notation. Let's consider the function here, f of x, which is this quadratic, negative 2x squared plus 3x minus 1. First, we're going to find the difference quotient. So this is going to be a heavy dose of algebra. All right, what are we looking for? We are looking for f of x plus h minus f of x over h. So we got to find that. First thing we'll do, let's just go ahead and find f of x plus h. That will require the most amount of algebra. So we're just going to replace every x we see in the formula with x plus h. So I replace negative 2 times quantity now, x plus h squared. X turns to x plus h, plus a 3, x gets replaced by x plus h, and then minus 1. And then let's just go ahead and multiply that out. That's going to be a negative 2 times multiplying out the binomial square, x squared plus 2xh plus h squared, and then plus a 3x plus 3h, distributing the 3 across the x plus h minus a 1. And then finally distributing that negative 2, we get a negative 2x squared minus a 4xh minus a 2h squared, and then plus that 3x plus 3h minus 1. So it's kind of a big mess to start with. But now we're going to subtract from that f of x. So let's calculate f of x plus h minus f of x. So we're going to take what we just got in the result, a negative 2x squared minus 4xh minus 2h squared plus 3x plus 3h minus 1. All of that, again, is just your f of x plus h, that output. And then subtract from that now the quantity f of x, which is the function, negative 2x squared plus 3x minus 1. We can see that the negative 2x squared will cancel with this negative 2x squared because it's being subtracted, so those are gone. The 3x is going to cancel with the 3x over there, 3x minus another 3x, so those are gone. And then this negative 1 minus a minus 1, those are gone. So a lot of stuff goes away, and we're left with the quantity negative 4xh minus 2h squared plus a 3h. So most of the difference quotient computation is finished. One last thing we're going to do is now take that f of x plus h minus f of x, which we just found above, and divide it by h, assuming that h is non-zero. So what do we get? Negative 4xh minus 2h squared plus a 3h, all divided by h now. Common factor in the numerator is an h or a negative h, depending on how you want to look at it. Let's just take out a h, and we're left with a negative 4x minus 2h plus a 3, all divided by h. Again, we're assuming h is non-zero, and hence, boom, boom, h's are gone. We're left finally with the result, minus 4x minus 2h plus 3. That is the average rate of change of this function, this quadratic here, over the interval x to x plus h. So if we just simply now want to pick an x and a corresponding h, we could plug it into the formula and compute the average rate of change of this function over the corresponding interval. All right. So hopefully you followed the algebra there. That's an example of how you would compute one of these things. And in the second part of this problem, we're going to now do just what I mentioned, and that is we're going to calculate an average rate of change of the function over the interval here, negative 1 to 2. So what does that mean? That's our interval. This is the interval x to x plus h. So you say, well, what's x? X is just the left-hand endpoint of the interval. So x is negative 1. And that tells us x plus h is the other right-hand endpoint, which is 2. And if we calculate what the difference in these two values are, x plus h minus x, or the h as we're interested in, that is just the difference between the values 2 and negative 1. Hence, h is 3. So we got our x, we got our h. Really, this is equivalent to asking what is the average rate of change from negative 1 to 2, where negative 1 is the left-hand endpoint, and then the right-hand endpoint 2 is 3 units away from 1 to the right. So we're going to just plug it in our formula. We know that the average rate of change for this function f over the interval now, negative 1 to 2, is, plug in x is negative 1 and 3 for h in the formula that's boxed right above. So that's going to be negative 4 times x. X is a negative 1. And then minus a 2 times h. H is 3. And then plus a 3. So what's that? Negative 4 times negative 1 is a 4. And then minus a 6. And then plus a 3. And you compute all that, you get 1. So the average rate of change of this function over that interval is 1 unit vertically per 1 unit horizontally. And there you go. There's an example of computing this. Now, what does it mean graphically? Well, let's take a look at the graph. Here in the picture is the graph of the function, the quadratic that we were just investigating. And the 2 dots that you see, those are the corresponding points on the graph. Here's the point negative 1 comma negative 6, and here's the point 2 comma negative 3. And so you see the horizontal change from x's negative 1 to x plus h is 2. That horizontal change there, that is a total of 3 units. And then the vertical change from negative 6 to negative 3, that change right there, the point at 2 comma negative 3, the output being f of x plus h. And then down there at the output of negative 6, that is the value of f of x. So that vertical change from negative 6 to negative 3 is 3 units as well. And so if we connect a line between those 2 points, which I'm going to do here with the fancy tool, draw and line, we're going to connect those 2 points, and there is the line, which we call the secant line, that's going through the 2 points of interest. And that secant line, this thing has slope 1. For every 1 unit I go over to the right, I go up 1 unit, over 1 unit, up 1 unit, over 1 unit, up 1 unit. And so there you go. This average rate of change expressed in a different form is just called the difference quotient. Hope you learned something and like it. And we're going to keep making these videos. Then everybody out there going to eventually just know math. And then they're going to say, wow, you know what? I love math. And I also love beats. Okay, it is time to bounce. Beats and math. Math and beats. Later.